Fundamental theorem of calculus. Okay. Keep in mind, the whole point of this really is to marry the two pieces of calculus together. We've been doing differential calculus, and now we're going to be doing integral calculus. Okay? And the fundamental theorem, it ties them together, you see. Wait for it. In a nice little bow. Yay! Or if you prefer a different analogy, it just makes it so that there are two sides. Oops. Or maybe not. Yes, two sides of the same coin. Yay. But anywho, this is what ties the whole thing together for us. Okay? Now your book, as most books do, breaks it into two pieces. There's part 1 and part 2. There is no such... It was never labeled thusly. There's just two parts to it, okay? So whether you, and I will always refer to it from now on as the FTC, the fundamental theorem of calculus. Okay? It's funny, there's a little fellow that teaches at PCC Sylvania. He's so funny. But he would always say that. Instead of saying integrating, we would now invoke the fundamental theorem of calculus. Just like that. Because it would be too hard to say integrate. That would be just too hard. So we're going to invoke the fundamental theorem. Anywho, this is the gist of it. So part 1, or one part of it, is such as this. So the integral from a to b of little f of t dt. Why t's? That's just the way the big kids do it. Okay, yeah, okay. That's how they normally write it. You could throw x's in there just as easily. Ain't no thing. Is equal to, oops, cap f. And what does cap f mean? The antiderivative. That's right. That's right. Or the indefinite integral, yes? But it is the antiderivative evaluated at b minus the antiderivative evaluated at a. And that's literally what we talked about yesterday. And it gets no harder than that in theory. In practice, it gets much harder. Okay? But the hard part is finding the antiderivative. Any idiot can stick in a number when it's all done, yes? And when I say any idiot, I literally mean any idiot can do that part. But finding the antiderivative, that's the tricky-dicky part sometimes. Okay, that's the part that you will be swearing and pulling your hair out and so forth about. It's tricky sometimes. By the way, did your mom mention that I called yesterday? Mm-hmm. Oh, that's nice. I left a message. Hi, this is Mr. Groom. And I had to call 2 people a week, which I'm not particularly happy about. But I thought, well, I'll call you. I'll get you out of a meeting maybe. But you're apparently already in a meeting or something like that. But no need to call back unless you want to. All right, yeah. She was nice. What? She was amused by that part? Yeah. I mean, it's fine if you want to, but I just, I don't really need to have a conversation. I just need to document that I did it. Okay? I will probably play musical chairs around this room with most of your parents and so forth. Hey, how's it going? I don't mind talking, but I usually have plenty of other things to do. So here's the problem. Some parents, you get on the phone and you can't shut them up. Am I right? Yeah. So we'll be judicious before I call your parents. I might be going, I don't think I want to talk to them. It might take too long. Okay? So on this first portion, we'll be doing kind of what we did yesterday. A little of this action. Oh my gosh. Let's do 1 over x. No way. Way. From 2 to 7. Alright. What will happen if I do that, Mr. Groom? Well, what's the antiderivative of 1 over x? Nice! Someone listen to me. This is exciting. Hang on. This is, by the way, that is a good picture. Yesterday we said this. Oops. Is equal to this. That's true. But watch what happens if I include a plus c right here. I'm going to go ahead and stick it there just for fun this time. Never again. What is the difference between this one and this one? The limits of integration. This is a definite integral, we call it. We call this one indefinite. Or if you prefer, it's just the antiderivative. There's indefinite because there's no limits of integration. Now, let's plug in the 7, shall we, kid? So it's the ln of the absolute value of 7 plus c minus the ln of the absolute value of 2 plus c. That is literally how I want to see it written. Okay? But wait for it. Notice how I put this whole thing into parentheses. You better do that too, or you will screw it up. Now watch me distribute the negative. Whee! I will end up with this. The ln of 7 plus c minus the ln of 2 plus, minus c. And what do you notice? The c's cancel out. Mr. Green, will the c's always cancel out? So when it's a definite integral, do I need to include them? No. But if it's indefinite, yes. So notice the difference there, yes? But if I put it, will it hurt anything? No, in theory, it'll cancel out every single time. Could you still screw it up? Well, yes, because a lot of us are talented that way. I know I am. Okay? Now, Scream has a question. If you saw this in a dark alley, could you clean it up at all? I feel like a subtraction of logarithms is a division, like so, is it not? Yeah, I'm just saying you could. Why do I show you that? Because I have a penchant for that weirdness? No. Because that's how the back of the book will probably write it, something stupid like that. So what I don't want you to do is to get in a panic because none of my answers match the back of the book, Mr. Groom. I don't know. I'm crying and all this crap. Just be aware, back of the books do that just to piss you off. That's the only reason. See if you're paying attention. Now, again, this is what Mr. Grimm does. I whip out the old the Desmos because that's what I do. What'd you get, stud?
We just can't do it. Just can't.
Oh, you freak me out, man. All right, so a little ln action here. I can't figure out where ln is. Oh my god, ln of the, wait for it, back into functions. Where's absolute? Why can't I? Oh, there it is. There we go. You can type it in too if you like, but I'm going to do that one. There we go. Minus the ln. I'd have to put the keyboard on, and I don't want to do that. I'm too lazy. 2. Oh my gosh, it's 1.25. What? By the way, do I need absolute value for this one? No, because they're both positive, yes? But if they were negative, I'd need it for sure. Now, what if I just did the ln, of course, of, and I'm just going to leave the absolute value off this time. Shut up, it's the same. Okay? So if you have it written as the top one, the back of the book has the other one, see if they come out to be the same when you plug them in. Oh, they're right. Then you're right. If you can't necessarily get there from here yet, I'm okay with that. But hopefully I'm going to learn you some new algebra. Well, we're going to review some good algebra too, and hopefully it'll be better by the time we're done. Okay? Yeah. So there's that. That's pretty cool. Here's another one. Let's do the sine. We talked about this one, so I'm going to do it. Screw it. I'm just doing it. I don't care. Whatevs. By the way, well, we'll do it this way first. Okay, that's cool. Let's go 0 to pi over 2. Because then I don't have to think. And I don't like thinking. It's too late in the day to start thinking. Okay. All right. From whence did sine come? It is the derivative of whom? Negative cosine. And I would totes agree with that. Oh, but this is a chain rule dealio, yes? So if you were to take the derivative of this, you would end up with 2 sine 2x, wouldn't you? Right? So what do you have to do? Divide by 2, right? Now we're going to get into more of that later, but we talked about that yesterday, so it's not like it's a huge dealio. We're going to evaluate that from 0 to pi over 2. All right, let's plug it in, dog. What is 2 times pi over 2? It's 2 times pi over 2. It's pi. What is the cosine of pi? The cosine of pi. If you get lost on the unit circle, you should probably kick yourself in the butt because that's ludicrous. Pi is over here. What is the cosine of pi? It's -1. Yes? And so it's -1, so +1, yes? Over 2. You see that? It's +1 over 2. Minus, always minus. Always, 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 always. What is 2 times 0? 0. And what's the cosine of 0? 1. And so it's over here, it's 1, so but it's negative, so it's negative 1 over 2, so the answer should be 1. Now, Mr. Groom, can I check myself on the old Desmos and see how close that is? Well, probably. What if I typed in sine of 2x? What? What? Now, let's zoom in just a skosh. Let's put this on the old projector-rooney mode. Right on, right on, right on. Look, friends, this is 0. Yes? And this is pi over 2, isn't it? How much area is there under this curve from here to here? Well, I don't know, but before you ask, this box right here is 1 unit, yes? Does it look like you could convince yourself that this little smidgen here and that little smidgen there added to this little smidgen here? I could probably convince myself of that. Yes? And so that's what we're saying. Ta-da! Don't be fooled that these boxes aren't 1 by 1, each of these little farts. Don't be fooled by that. All right? Because that happens to the best of us from time to time. Okay? They're oh my God, what are they? I don't know. Wait, where's a quarter at? Ah! These are 0.1s, so they're 0.01 little boxes. Apparently there's 100 little beggars in there now. If there are 100 of the 0.01s, it's 1, yes? It's just creepy. Don't do that. Just keep an eye on it, okay? Zippity Dippity. Here, let's try another one just for fun. Keep moving, keep moving. Don't get tired. You can do it. Here we go. Yeah, I don't know. I don't know. How about we try... Yeah, you guys try this one here. I'm going to go out and walk around the hall and make them feel uncomfortable for a few minutes. So while you're doing that, oh my gosh, it's you. It's no big deal. From 2 to 5. Try that. Try that. Try it yourself. And I will go out here. Okay?
Yeah, well, he said it's oh my gosh.
Okay.
I just want to make sure it's a cool project. They start to type out the directions for them, then I can kind of describe how to do it. But I don't show them.
Yes, it is.
Is it?
Bang, bang. What did u squared? What's the anti-derivative of u squared? Plus 1, so it's going to be u cubed divided by 3, right? So it's going to be 5 u cubed divided by 3. So listen, the anti-derivative of a So if I make this 3, I mean this 1. Okay, that's it.
So do you want us to find a common?
Just crunch that sucker into a calculator. Give me a decimal. That'll be hunky dory. Hunky dory.
Two because
Is it
did it actually?
Well,
Yeah,
not
I
whole
forgot.
composites.
Oh, that's not the right. Yeah, I forgot the story.
Child born.
That's not
I know, but I'm born.
People are laughing at us because we're going to the calculus. Anybody else not turning the form yet? Freaking losers. I did it. You got them, Mom. Just put them right in this little folder that you do.
They
Smell.
did not put the spread on the other.
Wait, do we have to go to first period for half an hour?
No, we're leaving like at 8:30ish. You're getting out pretty much right. You go to, you just don't even check in. Just come, get on. Well, just come here. Don't just get on the bus.
I don't know.
You're excused until at 2:30 when we get back. I did.
Yeah, I don't know. We got a negative number.
How did you get a negative?
You could very well. I don't know. Let's see what happens. Let's see. Let's see. By the way, lots of us are getting good answers. What are you looking at? What are you doing?
Just showing them you can do all this. So I'm in multiple layers. I'm checking.
All right. So, friends, let's check this out. So, I believe we all got this, or most of us did, yes? Did you get this? Hey, did you get this? So, 5u cubed over 3 plus 3u squared over 2 plus 2u or over 1, which is dumb. Okay? Okay. Now, if I was using Desmos.com, if I was using Desmos to do this in a way so that I didn't screw up stupid little errors, because I make them, what I personally would do is I would go, what is the equation? It was 5, is that right? So 5, I would do a cubed, right? And then divided by 3. And then I would do, what is it? Plus, was it 3u squared over 2?
Yes.
So 3. And you could even use a. You could even use u if you want to. I don't care. I just work here for now. Plus 2u. Yes? Is that right?
Yes.
Nice. And then you could simply hit the slider, and then you can click right there and type in your points. Now, what do we need to evaluate it at? Where? 7? No. What's so 5? Watch me hit 5. Oops, wait, stop. Don't do that. What are you doing? 255.83. I jot this down on a piece of paper somewhere. You with me? I jot it down. And then I go, let's put in a 2. 23.3333. And so someone's going to quote those numbers to me. What are they?
255.9.
So 255 point. 0.833333, right? Minus, what?
23.3.
Right? For evers and evers and evers. And when you minus them, you should get 232.5. Is this true?
But I got negative.
You minused them backwards. That's the only way to screw this up. You minus them backwards. That's it. Did that make sense? Now, if I had a TI-89, if by God I had paid for a TI-89, then one of my favorite, coolest features of the TI-89 is this. And what was the function again? 5x squared. Is that right? Divided by... No, x cubed. X cubed divided by 3 plus 3x squared divided by 2 plus 2x. Yes? The such that button right here. Such that. Hit the old such that button. X equals, what did I say? 5? Bam. Oh no. Watch, I hit diamond enter. So there's your 25, yes? 2, whatever it says. And then I backspace and put a 2 in there. Give it the old diamond action. Boom. And then I minus them. That's quick. I hate making stupid mistakes. So, use Desmos. Use the 89 to evaluate. For God's sakes, don't make a stupid error because you can't times correctly or something somewhere. Okay? It's dumb. It's just dumb. They're good?
Do you want our thing set up as z equals, or do you care at all?
Why, I don't know that I care.
Okay, because
I don't know that I care.
I got that guy there.
Perfect.
Okay,
Perfect.
cool. I'll leave.
And you know what would be interesting? it'd be really interesting if you found another point
On the plane.
on the plane and see if it works for that. Right? For instance, if you found another point on that plane and you drop it in for x, y, and z, it better equal 0. Yes? Or another way of thinking that is, yeah, solve for z, and then pick an x and y
Could I just use
and compute the z.
Can I just use one of the other points that I used?
You could.
Double check it.
You could. That'd be pretty tight. All right. But even maybe, I think it would be maybe even a slight bit more impressive if you used a different point.
But it's all like kind of like rough.
No, I know. I'm saying, but it's kind of cool. Whatever. Whatever. All right. Now, question on that. Okay, Mr. Grimm has another question. Watch me do this. What? Wouldn't it be this then, Mr. Groom? Oops. Which is what he did over here. Did you get the same number I got? But negative. Friends, there is actually a reason for that. If you do this, and at this point you're like, Mr. Groom, why would I ever do that? But you remember back in like first grade when you learned to times by ones routine? And then you said, why would I ever times by... Well, first you went home and said, hey, Dad, what is 7,862,112 times 1? Right? Yeah? Yeah. Because you were pretty impressed with yourself that you could do that. But then after that, you're like, timing by 1's kind of lame. Until you get to fractions, yes? There is a reason for why we do some of this crap, yes? Same thing with adding 0. You're like, why would I ever do that? Completing the square. Right? Because you add and subtract from the same amount, yes? So what are you basically adding? 0. Okay? This is another deal where this will show up later on. Later on, this will be a deal where we might actually rewrite some things to take advantage of this property. Okay? So it's not as weird / goofy as you think it is. Because people would think, well, that's kind of weird, Mr. And I wouldn't argue with you if you thought it was odd. That's how it is. Now, all right, let's try this one here. This is a modified one of the one in the book. At this point, you don't know how to do it the way it is currently written. Right? I was going to write 0. Is that okay?
Sure. You can try it.
I feel like 0 in the basement, kind of a problem. I'm going to go from 1 to foe, I think, instead, if that's okay. Okay. Now, Lils, you do not know how to do this kind of a problem yet. But you actually do know how to handle the algebra. So let's look at the algebra to rewrite this fella. Oh, by the way, we see you tomorrow. No, wait. It's your birthday today, isn't it, Octal?
What?
Isn't it your birthday today? Liar. Somebody had their birthday today. It's yours is tomorrow. It was your birthday. I'm going to go look at it.
Mine's on Earth Day, April 22nd.
All right. Maybe I'm just a weirdo. I don't know. But listen, friends, what I don't want to say is equals. I want to look at this thing here. Can you simplify that at all? I feel like you could rewrite it as this over this, yes? Right? And when you divide, you minus, yes? So this should be x to the what? The 7/2, I believe. This should be just x, right? I just simplify. That's freaking algebra 2 or something, or algebra 1. I don't even know. Somewhere back there. It's back. You should know how to do that, okay? Now later on, you're going to have other kind of nasty stuff down here, which is not simplifiable, and we have ways of making those talk too. But this one we can simplify. So here it is. So 1 foe. I'm going to rewrite this mess instead as this guy right here. Okay? And what is the antiderivative of x to the 7/2? Well, I'm going to add 1. So it's going to be x to the 9/2. And then I'm going to divide by 9/2. And minus x squared over 2. Now it's at this point, Mr. Opdahl says, geez, when you divide by a fraction, it looks stupid. So instead of dividing by a fraction, shouldn't I just times by its reciprocal? Yeah. So it's really 2/9 x to the 9/2. And you can see that if you were to bring this down, take a derivative, it would be 9/2 times 2/9. Should give you 1, yes? Which is what you had to start with? Minus x squared over 2. And again, from 1 to foe. So I'm going to go ahead and plug it in here. I think I'm going to need a calculator for this because, well, no, I won't. I can do this in my head. This isn't that bad. Oh, what are you doing, jerk? You jerk. Calculator down and back away from it. There we go. All right, what is the square root of 4? 2. And what is 2 to the 9th power? Yes, you do. 2 to the 7th is 128. 2 to the 8th is 256. That means 2 to the 9th is 512, isn't it? That's what I thought. So 512 times 2/9, whatever that is. 4 squared is 16 divided by 2 is 8. Hey, what is 1 to any? That's 1. So it's minus 2/9 minus a half. And now at this point, you can get a calculator out if you want. I don't want to do any further than that. I don't care anymore. Okay. Ta-da! I just don't care anymore. I'm just going to leave it like that. Smile, Allie. It's fun. This has got to be your favorite class of the day, right? Or physics. Certainly better than English, right? Not judging, just saying. English. 98 and a third. Nice. Do you buy that? Yes? Nice. All right. Let's try something else kind of cool. What if, hypothetically, I wanted to integrate this function? Do it now. I'm going to wait. I'm going to watch. I like this. It makes me mad. Nah, I'm hearing funny noise here. Can you check these out? What'd you get?
I got 0, but back to you.
You got 0? That's right. Let's see why. Let's see why. It turns out that x cubed looks like this. Here's neg 2. There's positive 2. The area on this side and the area on this side look the same. So why don't they add up? Well, friends, if this were my velocity curve versus time, I had a negative velocity to start with. Meaning I was going a certain direction. I was going the opposite direction, yes? Away from, or towards home, or whatever. I don't know what we're going to call it. And then I had a positive velocity. Where did I end up? Right back where I started from. And so we define this area down here, area under the x-axis, we define to be negative area, because it's below the x-axis. Positive area fits above. This is probably the first one we've done where I've made it so that it was negative, or positive, positive, negative ones. And so in this situation, because they're like mirror images of this guy, it adds up to 0. Now in the future, it'd be really cool if you're paying attention here. X cubed, we call this guy an odd function, don't we? That is, he has symmetry to the origin. Yes? And so in the future, if you're integrating an odd function, right, oops, what are we doing? Dx from negative a to positive a, no, then you write b, not a kid, right? It will always give you 0 for an answer. Always, 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 always in the future. If you see it. Frequently, we don't see it. We're going 100 miles an hour, and frequently we get down, you're like, oh, god dang it, you got a 0. Yes, it is odd, so yay, I'm right. Very rarely do I slow down enough to go, I should check this to see if it's odd first. Or look at a graph. But listen, friends, you should always look at a freaking graph. Okay? And so you're like, I don't know if it's odd or not. How do I know? Well, it has to have origin symmetry. So you go x cubed. OMG gosh. It's like it has origin symmetry. And so if I write in x equal negative 2, and I write in x equals positive 2, it's literally like they're mirror images of each other. Nice. But of course, we know that isn't true if you put a +1 on, or a +1 or something on here, right? It is no longer symmetric, is it? No, siree, Bob. In fact, look, you're going to have negative areas, and you're going to have a bunch of positive areas. You're going to have more positive than negative, so therefore you will have a positive area when it's all said and done. Yes? Nice. We'll be doing that quite a bit this year. We'll be doing some cool little shortcuts like that. Hey, Mr. Green has a question. What if we integrate x to the 4th plus 4 from negative 2 to 2? Try that while I go talk to them. What's up?
So we have.
Who these people are? What'd you get? What'd you get? What'd you get?
0.
No, you didn't, liar. You fell into my trap.
No, never mind. I got 28.
Good, I hope so. I hope it's something not 0, yes? Now listen, I graphed it like you told us to every time. I don't know if it's 28. I don't know if it's 28. But I do know this. It's this area here, yes? But you know what I feel like? It seems like this side is the same as that side. Because this is an even function. That is, it has symmetry to the y-axis, yes? So watch. In the future, when you see one of these, if you see it, and you may or may not, actually you will see some of these later on this year. Oops, I'm going to write even function here. I could rewrite that as 2 times the integral from 0 to a of this even function. Does that make sense? I could find it from one side and then double it. Okay? We will use that trick later on. Okay, I just mention it now because whatever. It's very straightforward though. When someone like this goes, oh, I know it's 0. Okay, I did it on purpose to see if people would fall for it. This is clearly not an odd function. It's an even function, right? And again, if you graph, you're like, everything I want is above the x-axis. It's got to be positive, yes? All right, so let's do this here. It's x to the 5th over 5 plus 4x. Is that right? Negative 2 to 2. So that would be 32 fifths plus 8 minus negative 32 fifths. Plus, minus 8. And so if you distribute the negative, like I've showed you, you end up with 32 fifths plus 8 plus 32 fifths plus 8. Wow, that's 64 fifths. 64 fifths, yes. There it is. Plus 16, which is 80 fifths. So it's 144 fifths. True det. Yay. Or you use Desmos like I told you. Or you use J89 like I showed you. And you got, what is that? 20.8. Yay. 28.8. Yeah, whatever. Yeah. Yay. That's it. That's what you're going to be working on today. Okay? Now, tomorrow we're going to, well, no, I think tomorrow I have a work day planned. Is that what I have planned? Anybody look at the calendar? No, I'm going on Monday. The calculus musical is on Monday. By the way, I've caught a lot of crap about that. Mr. Groom, you're going to a musical? Yes. About math? Yes. Why are you going? Basically to get out of school, but whatever. Okay.
I thought you were just joking.
No, it's a real deal.
It's so weird.
Hey, listen to this one, Neil.
This is
What is physics?
Nice. There, I'll play it again. It's Sheldon from The Big Bang Theory when he's teaching Penny some physics.
What is physics?
Nice. It makes me happy. I'm bored. All right, here we go. Calculus, give it to me. What is on the schedule for tomorrow? I forgot. Oh, yes, no. Ooh, yes. I'm going to push substitution back till on Monday. No, I'm not. Until on Tuesday. That's what we're going to do. Tomorrow, workday / I might cover the second half of this. So you should be on page 214. No, 314 on your homework, I think. Yes? That sound about right? That's where I'm on. Page 314 on your homework, which is not on there. So I'm going to give you some problems. Here it is. For some reason, it didn't get put on there. I don't know. Must have changed it last year. No, dear. It's no. See, we did 307 the other day, and apparently for some reason I skipped page 314. I don't even know how that happened, so I don't even care. I'm going to make up some numbers if that's okay with Lily. I'm going to go 5 to 39 every other odd. And don't tell me if I'm wrong, it doesn't end up on the right one. I don't care. Just do the last one anyways. Okay? I'll just do it anyways. Okay? It'll be good times. Now, I'm going to go watch the other guys, get some work done here.